Before we get started, this will be session for Palo Alto, and I'll be your trainer for Palo Alto and for a few other modules of Firewall Mastery that you might have been enrolled with. So this one is specific to Palo Alto, and my name is Navin, and I will be your instructor for Palo Alto and the rest of the firewall modules, depending on the availability. So most probably I will be covering Palo Alto and FortiGate for you guys. All right. So a little bit about myself. I've been with Network Journey for a couple of years, and I have about 8.5 to 9 years of experience in network security and cloud infrastructure. So I have been with Network Journey and in the teaching domain for about 3 years. So um, with regards to this batch, I think we will be covering Palo Alto along with Panorama, basics of Panorama. I'll be giving you stuff how the Panorama works, because that's how the real time Palo Alto infrastructure is deployed. So without knowing Panorama, just the standalone firewall wouldn't be giving you much of a hold in the industry, right? So you should be seeing the 5-in-1 bundle combo ad in the screen. So this is where you go register. So you can just go ahead and register your name for the session for whatever batch you are supposed to enroll with or you're interested in. And this will be the batch timings or the demo timings, you would say. And you will be having the contact details at the bottom. So a little bit about our features with Network Journey. So what you will be probably getting with us. So it will be an online instructor led, and we'll be having all the 5 firewall modules covered in one single bundle, so which you can take. And you are allowed to retake the session. If you have missed some sessions out of this batch and you wanted to retake, you can always contact our backend support team and retake the sessions. And most importantly, you will have close to 3 to 5 months of server rack access to practice your labs and appear for the examination if you wish to. Okay, so you will be having the contact details mentioned in the chat as well, the later part of the session. So you can contact our backend support team for any support you would like. So if in case you have any issues with the lab, you probably can contact our backend support team and they'll be available 24/7. And to know how the lab topology would look like, so since we are going to focus on Palo Alto, if you just look at the Palo Alto topology, this is how you would your experience would be for your. For some reason it doesn't open for me, but you could see here on how it has been designed. Yeah. So this is how your lab would look like for your Palo Alto or Cisco FG, FMC, or FIOLTM, or if you're taking Checkpoint or FortiGate. Okay. Okay, so you could check for the contact details below and contact us for enrollment. Okay, and finally, as you guys might have already known, if you've taken a course with Network Journey, you will be getting a certified sign by our founder. All right. Okay, so you could make a note of the contact details. Probably I would be pasting this in the chat details in the chat as well later on. But if you'd like to take a look, I'll just pause the screen for some time and you can get in the details of the phone number and email address. Okay. Cool. Then so yeah, again regarding the agenda, I plan to have half of the time that I'm going to spend today on theory, and the second later half on some sort of practical, because I know if we go ahead with the theory for complete 2 to 2.5 hours, it would be pretty difficult for you guys to sit and listen. But I thought that's the reason I thought of having a interactive session for 1 hour, and then we could jump into the lab to see some basic configuration to get used to the GUI basically. Okay. So this will be the agenda for today. So let's see how far we could cover. Most probably we should be able to cover most of this stuff. So let's quickly get started. Okay, yeah, there you go. I think we have the link I've been showing you so far. So you can just go through the link from your side too, and then try registering by contacting us. All right. Okay, let's quickly get started. So first thing, before we get in, I wanted to have an interactive poll or an interactive question and answer session on, you guys can answer me or start with what is your experience with networking and what is your background, and probably we can give a chance to, like, say 5 to 6 people, and we will quickly get going with just to understand how the crowd is about, what the crowd is about. Yeah, you can unmute yourself and just try letting us know about your experience or your exposure to networking, and where are you guys from, and just to get an intro going. I see one person has unmuted himself, Somash BN. Yeah, anyone can unmute yourself and try giving an intro of yourself for just say 30 seconds or 1 minute. Yeah, brief 30 seconds should be enough.
Okay, I think I will just make a start. My name is Mazahir Contractor. I am based in Dubai. I work for a company called Mark Ellis. It's a consultancy company. So they have a few branches around the world, and I manage the IT infrastructure as a whole. The whole agenda or the whole point to attend the session is to know about the different firewalls and how it could be implemented in my network, and uh, how we could how I could make it better from whatever the setup is there. And yeah, I think that's pretty much it. Yeah, thank you. And yeah.
Yeah, thank you. Thanks a lot. Right. So anyone else? Yeah, that's should be sufficient for an intro. That's a brief 30 seconds about you and your experience, and what made you join Network Journey or take up the course or something like that.
Hey, this is Shekhar here from Bangalore. I have 13.5 years of it in network security, so my expertise on network routing switching and ASA firewall, FortiGate firewall, FTT. So with this Palo Alto, we are doing migration from all the ASA to FortiGate and the Palo Alto for the data center firewall. So I expect learning more on the Palo Alto from this training.
Okay, thank you. Thanks a lot. So probably 2 more people, and then we shall get started.
Okay, thank you.
Yes, go ahead, please. Anyone else? Okay, I'll get a count of 5, 4, 3, 2, 1. Okay. All right. So let's get started. Let's get the things going with our session. So, as I said, the agenda would first be an introductory agenda about firewall, and what an next generation firewall is basically going to do to us, and why are we basically looking forward to go with next generation firewall, or already started using next generation firewall. with respect to layer 4 firewall, for example, in ASA. Okay, so let's consider a router here. So when you consider a router, and when you consider any type of traffic, for the forwarding table to forward the traffic, it should have an ingress interface and an egress interface, right? So let's say this is 1/1 and this is 1/2. And when the routing table lookup is done, the router would forward the packet from this interface to that interface, depending on where the outside interface has to, where the exit interface is configured to go for that specific network where the user is trying to reach. Okay, so let's have a parallel scenario where a firewall in place of a router is connected. So the firewall also does the same thing by routing the traffic from one interface to another, depending on the forwarding table. But what a router could do and firewall couldn't do, or what a firewall could do and router couldn't do, is what we're going to see now. So basically, a router is basically going to just do routing. On top of that, in terms of security, you could configure a router as a zone-based firewall. Or if not, if the feature is not available with the router, certain routers, you could do access list, where you restrict the traffic based on IP or short layer protocol, TCP or UDP protocols, or port numbers, let's say. So where in case of OSI model, you think of layer 3 and layer 4. I wouldn't say inspection. It won't inspect any protocol, but then it just restricts the traffic based upon the access list that we have defined. So inspection is a different story, where the firewall, including ASA, does a protocol inspection, where if or let's say stateful inspection, where if once if traffic is being initiated by a user here and towards this server, SRV. So when this is a TCP traffic of, let's say, port 53 for DNS, or maybe let's take a TCP protocol, maybe we'll see 21. And for this traffic, for this TCP traffic, the forward traffic, when it is allowed on the firewall, the reverse is automatically allowed for the same connection. So if an IP of 10.1.1.1 is trying to reach 100.1.1.1, this traffic, when it's allowed by the firewall from the source to destination, the return traffic from the destination to source for the same connection is by default allowed. That is what you call it as stateful inspection, statefulness of a firewall. So the firewall basically maintains the state of the TCP connection so that it is able to allow your return traffic as well if the forward traffic is allowed on your firewall, right? So that is basically not possible with your router. Meaning it's not going to inspect anything, inspect any protocol, so that it can maintain the state of the connection and allow the return traffic. So if you are to allow return traffic of the connection as well, you got to have an ACL defined on the interface. Okay, or if there is no ACL defined, it means that everything is allowed. So that's what difference between a router and a firewall would do. But in general, if we talk about firewall, there are about two basic firewall types. So firewall that works for layer 4 or up to layer 4, it inspects up to layer 4, and the firewall that is able to inspect up to layer 7, which is next generation firewall. Okay, so how does these two differ? So let's go back. I'll just erase all of this. So when I take layer 4 firewall, so in this case, let's take an example of an ASA. As I said, both layer 4 and layer 7 firewall, layer 7 inspection enabled firewalls are capable of having the capability of inspecting the connection and maintaining the state of the table. So both are stateful firewalls, basically. So how does this and that next generation firewall would differ is that this firewall can inspect up to layer 4, which is TCP or UDP. So when it is over TCP or UDP, which is basically a layer 7 application. So in application level, this ASA will not be able to inspect or secure anything. So only when the traffic comes to a layer 4 level, this ASA would be able to do something about the traffic and inspect the traffic or secure something on it. Otherwise, when with respect to application level, where user is accessing a specific application, or what multiple applications in the same connection that the user is accessing, will not be able to, the ASA will not be able to figure that out from itself. Whereas the next generation firewall here does so much things in layer 7 level and much more for it to be a standout firewall, where ASA is no more being used. Just so, if you think of use case of an ASA, you probably see them used in any connect solution where users are allowed to connect to the network remotely. So only for this specific solution, you are currently using ASA. Otherwise, as one of the candidate told us, we are quickly migrating, or sooner we'll be migrating from ASA to any next generation firewall. So Palo Alto being the leader in the market, there are more chances of people migrating to Palo Alto, or as a secondary, you could say FortiGate firewall. Okay, so ASA, the drawback of ASA is the advantage of ASA over a router is that its statefulness. It is able to maintain a stateful connection. Stateful inspection is able to do a stateful inspection, maintain the state of a connection. And the disadvantage or a con would be, when compared to a layer 7 firewall or a next generation firewall, is that it's able to inspect only up to layer 4. And anything above layer 4 is not in control of the ASA. Okay, so let's talk about the features of next generation firewall, or Palo Alto in our case. Okay, what does Palo Alto do in addition to that of what an ASA could do? So first thing, as Palo Alto, as ASA is capable of doing routing or stateful inspection, Palo Alto also could do the same. So first thing is stateful inspection, right? Okay. So second thing, it could do so much more. So let's quickly start talking about the features that Palo Alto could offer. So there is something called App ID, where you as an administrator, with the help of Palo Alto, will be able to identify which application the user is basically using. So you might be using a port 443 to open up a connection, but 443 in general, when he launches the application, it could be SSL. But after he launches the SSL application, or after he launches the URL, if he goes to Facebook, let's say, the application will be identified to be Facebook. So after he gets into Facebook, logs in, and if he gets into a chat messenger, the application will be identified as FB chat, Facebook chat. And if he gets onto a video call with someone, the user gets onto a video call, or if he checks some feeds, there is a specific sub application that is involved that could be identified by Palo Alto. So all this is done using the App ID signatures. So with the help of App ID signatures, the firewall can identify the application more than an SSL application. What would be the first application that the firewall would identify when he launches the HTTPS connection? So when he does HTTPS / and gets onto the URL, the identification of application would be SSL, and thereafter, whichever application or website he launches or application he uses, it will be identified as that specific application using the signatures. Okay, so that's one specific feature. There's something called wildfire. So this is again a topic of its own, where in general, if I have to say what a wildfire is, it's able to identify a zero-day attack. Let's say a user tries to click a phishing link via a phishing email, and he gets to the URL, and the response comes back, and this user is compromised, and the firewall sitting in here is watching everything. So this firewall, what it does is it takes the phishing URL and puts it into the threat IDs that is already available using which is pulled from the Palo Alto Update server using its threat license or wildfire license. So if it is not identified to be a valid threat, and if it's a valid threat, it will be blocked automatically. But if it is not blocked and the user is compromised, this URL, which is accessed by the user, will be sent to the wildfire sandbox, which is again a PC, which is sitting in the Palo Alto's cloud, public cloud, and that will be trying to reach the URL that the user actually reached, and will get the response, and that's analyzed by the Palo Alto Update server or wildfire update server, and a threat ID will be marked for that specific URL, and it will be distributed to all the firewall that involves having a threat license or wildfire license. So basically, this PC, after being compromised, and the firewall noting down everything, will act as a proxy for a client, using the sandbox, and identify the threat involved into this URL, and then it will be distributed to all the firewalls in the network, in the global, all the firewalls in the globe to know about the threat and make use of the threat ID to block the connection to this URL when it is requested from any other user in the world. So we will discuss about wildfire in detail on how it's done and how it's configured. But for now, just know that wildfire is basically used to mitigate the zero-day attack when there is when the threat is not seen before, and how firewall this Palo Alto firewall mitigates it and lets other Palo Alto firewall users know about it, administrators know about it. Okay. So what else it could do? So let us talk about a few other features, and then we'll get on to the packet flow. So let's not talk about all the features today. Okay. So the next thing would be user ID. User ID is something that's pretty useful. Let's say a user is sitting in here and he's connected to a switch, and that's connected to a firewall and to internet. Okay, so this user, amongst other users, let's say 200 plus users in the network, amongst them, this user is basically trying to download some files from internet, which is choking the network's bandwidth, ISP's bandwidth, and other users are facing slowness in the network, and you got to go check who's using what, and you obviously will have some sort of GUI based report generation tool or a graphical interface, ACC monitor, to view all the logs with respect to which IP is utilizing more data or downloading more stuff or uploading more stuff. But wouldn't it be good if you know who the user is basically doing it? So you know that it's 10.1.1.15, that's the user's IP. So for you to go back and see what the ARP entry of it is, and then go back and check what the user's port is, and then go back to check which user is basically accessing it. So this is good, and this can be done within few minutes if the user is using a LAN. What if he's using a Wi-Fi? When you're trying to trace the MAC address of the user, it gets to your AP's connected interface, right? So when you're trying to trace back the user's IP address, it gives you a MAC ID, and that MAC ID would be your AP's connected interface. It will not be your user's physical MAC address, because the user will be connecting to the specific AP, and you got to go and figure out where the AP is, and in that AP there will be about a few tens of users connected, and you will never know, or it will be taking a lot of time to know which user is basically doing this work. So to avoid all that, you're going to use something called user ID, where let's say you're using a Active Directory server, an LDAP server on your Windows. You're running a Active Directory server onto your Windows 2016, and the users to IP address database is can be replicated onto your Palo Alto device, and you will be able to receive. So there's a logging called traffic logs. You'll be able to receive your source IP address of the user. So let's say in this case is 10.1.1.15, and let's say your domain is nj backslash, and the user is Navin. So this will be your source information available on your traffic log. So for this, what you would do is that let's say you have an Active Directory where for a specific user's IP address, you will be mapping its AD name, and for that the user should be joined to a domain. So it should be it should be a part of ng domain, and his name to IP address mapping will be forwarded to Palo Alto. There should be a specific configuration you should do between these two, and once this database is received by Palo Alto, you can even do it through an user ID agent that's in between the Palo Alto and AD. You will be receiving the traffic log in this fashion, where for the specific IP, what's the user who's mapped to this IP address. So on the monitor ACC tab, on the graphical user interface tab, if you see that the user who's using the highest amount of bandwidth is this IP address, with the help of user ID, you'll be able to identify which user is basically it. Right? Not only this one, when a user is trying to ask for accessing a server, let's say he will be a part of 10.1.1.0/24 network, and every day he powers off and powers on his PC. After he comes to office, he'll be getting a different IP basically. So you can't restrict the traffic based on the IP address. Rather, if you have a user ID enabled, you can just say for any user, so any IP address, for this specific user, I'm allowing the traffic. So you can restrict the traffic rules based on the user ID. So that will be more granular way of controlling your security policies. So which means whichever IP he connects to when he switches on the laptop after he comes to office, if the AD of his if the domain he logs into and the username he logs into is this name, only he will be allowed access to that server, because he's the one who requires access, and that's what we are doing. So we're not allowing any unwanted access to anyone, even in his team. So that's how granular your rule base would be made if you have all the features enabled in here. Okay. So apart from that, on top of my mind, I think I have something called a sinkhole. So that is again, if a user is basically trying to use trying to access or open a connection for a domain, let's say xyz.com, and this is your firewall, and this is your DNS server, and this is your user. So when he tries to resolve this to an IP address, and this is identified to be a malicious domain, with the help of your Palo Alto, it identifies it to be a malicious domain with the help of DNS signatures. And the traffic, when it reaches the firewall for DNS query, it will not be reaching from the user's IP address, but user will be reaching out to the DNS server, and the DNS server will be sending the query for you for the first time. So you will not be able to identify who the user is basically to know who is trying to access this one. So to track the user who is doing this or accessing this malicious domain, you configure an IP, a dummy IP address here called sinkhole IP, and you'll be configuring a security policy to deny that traffic from the user's network to this IP address. And when the DNS server requests for this domain, this IP will be returned as the DNS response, and the user will be sending out a traffic for the dummy IP that we have sent as a DNS response. And on the traffic log, we will be having a deny rule already in place for the specific IP address that we have defined. And the traffic log will say who the user is basically trying to access this IP, which we have defined as a dummy IP here. So with the help of that sinkhole IP, you will be able to identify the user who is basically trying to access your unwanted URL here. That is identified by Palo Alto. So that's in short what is DNS sinkhole. So you have a lot of features like this in Palo Alto that you can know. But for now, I think these 4 should be more than sufficient. We'll get to talk about the packet flow in Palo Alto. So the best reference page that you can use is the Palo Alto website itself. So one of the best things that I would say with Palo Alto is the documentation. So you have a very nice documentation for all the topics that you could refer. So this diagram would probably be your helping hand if you are appearing for an interview and if you want to just quickly refresh your knowledge on Palo Alto's packet flow. Okay. Let's quickly follow the diagram here. So as you know, for any layer 3 device, you will have an ingress and egress interface as I initially told you. So if you have an ingress and egress interface, there will be an ingress stage and an egress stage in a packet flow or life of a packet of Palo Alto. So in life of a packet of Palo Alto, you have 5 stages, so of which the 2 stages would be your ingress, when what happens when the packet enters the firewall, and egress, how the packet exits the firewall, right? So in between that, you have fast or slow path. Okay, so you have content inspection and app ID. Okay, so totally you have 5 stages. So we'll try to look at one by one. So ingress stage is pretty simple. It is as similar to any layer 3 device that would process the packet for any traffic. So in ingress stage, it just collects the specific information about the layer 2, layer 3, and layer 4 of what the IP address information is and what the destination MAC is, what the source MAC address is, what the source and destination IP is, and the ingress zone. So let me write it down a little clearly. So the first thing would be our source and destination IP, and collects the source zone. So zone is basically your identification that you give to a specific interface. So let's say you have 4 sub interfaces that points to your LAN network, and the common access policies that you define for those 4 LAN networks would be the same, except for a specific access rights that you give for the network in general, in separate. So for those 4 networks, you could probably define a zone called corporate. And for generic internet access or any generic access that you could provide for all the 4 networks in common, you could use the corporate zone and then have the IP address as any, and then reference the zone for allowing the traffic, right? So it's just an identity that you're giving to a specific interface. Okay. Okay. So the first information it would track is the source and destination IP, source zone, and destination MAC, source MAC. And it would probably see what is the destination port number as a part of layer 4 information. Okay, so it also checks something like if the traffic is coming in which is fragmented, it has to reassemble the fragment, right? So reassembly happens if the traffic has come in fragmented, and rightly so. If you could get it right, when the packet gets out of the firewall in the egress stage, if the packet is too big to be sent out as a single packet or a single frame, it will be fragmented there and then sent out to the next device, okay, on the egress interface. So here reassembly happens if the traffic is fragmented, and in the egress stage, the traffic will be fragmented if it has to be, okay, depending upon what the receiving buffer is of the interface. Okay, so that's about it. So if any of the information collected, let's say on layer 2 or layer 3, if there is any processing error that happens with the CRC for layer 2, or in layer 3, if the state of the packet is not proper, if there's any error that it notices with respect to layer 2 or layer 3, it will discard the packet, else it will forward down. Okay, the last thing that it does in the ingress stage is that it checks if the traffic is an IPsec traffic. Okay, so it checks if the traffic is an IPsec traffic, and if it is so, the traffic will be encapsulated or encrypted, and it is supposed to be decrypted to know what the IP packet that's inside the tunnel, right? So it does that, and then does the processing again. Okay, so that's the ingress stage. And before we go to the fast path or slow path, so I said fast path or slow path when I wrote down those packet flow stages. So why? Because it either chooses one of them based on the criteria whether the traffic is a new traffic, or if the firewall session is already found on the firewall, or if it's a new session. Okay, so if it's a new session, it goes through the slow path for it to collect some basic information and form a session on the session table, session formation. So basically, session formation stage is the slow path. And if the session is already found on the firewall, it follows the track of the fast path, right? So let's consider it's a new packet. So if we come back here to the slow path, it basically identifies a few other information. So if you see, it checks for the forwarding table, forwarding lookup, to know what the egress interface or zone is. Okay, so and which virtual system it has to go out to. So virtual system is basically like a virtual firewall. So you divide your firewall logically into two firewalls, right? Two instances. So it checks which virtual system it belongs to, and what's the forwarding table, which interface it has to go out to, and what's the next hop IP, and so on and so forth. Okay, so and then it checks for the NAT policy. Okay, so when it checks for the NAT policy, it specifically checks if NAT policy is applicable, and if the applicable NAT policy is for the destination of the traffic. If it is for the destination of the traffic, and if you understand why it specifically checks for the destination, there is a way that Palo Alto Firewall works. When the traffic is for the destination, if the NAT is for the destination of the traffic, the destination zone that we will be defining in the security policy would be your post-NAT zone. That's the thumb rule when you are writing a security policy on your for destination traffic. So since you're writing a pre-NAT IP and post-NAT zone on your destination of your security policy, the zone is set to change in this case. So that's the reason if it's a destination NAT applicable traffic, you will be going on to do a forwarding lookup again and then come back down, right? Only if it is a destination NAT. If it's a source NAT, it doesn't care. It just follows the flow again. If it's a destination NAT, it does the forwarding lookup again, because while writing a security policy, we write the policy of the destination based on pre-NAT IP and post-NAT zone, right? Okay, so when you come down, you have security policy lookup. So far, I think I have told you about the app ID stage, application identification. So far, we haven't identified what application the user is using for the specific traffic. So we keep it as any. And then for the other parameters that we define in the security policy, we just do a forwarding lookup, the policy lookup, and then see if the policy is allowed or denied, and then install a session, right? So while the session is installed in the table, it doesn't know which application it is, okay? And when it comes to fast path, it's the NAT will be implemented here. So here the NAT is going to get looked up if NAT is available or not on the slow path. When it comes to fast path, the NAT will be implemented. Okay, so here is where the NAT is implemented, and it does one more thing. If the firewall state of the TCP traffic is not identified as an active state, it will discard the traffic. So what does that mean? So when let's say a traffic comes in, when the first TCP handshake happens, the first traffic that packet that the firewall should see is the SYN packet, and the response it should see is a SYNAC. And the response from the source would be acknowledgement, and then the data. So if there's any change in this this step that is supposed to happen for the TCP, it will declare that this packet is not in an active state, and it will discard the traffic. So let's say, for example, if the TCP session is not at all found, handshake doesn't happen, and directly a data packet is coming in for a specific session, it will obviously get discarded because the first packet it's going to expect is a SYN packet for TCP. Okay, so if it is deviating from what is expected from the firewall, it will declare that the session is not in an active state, and it will declare the traffic as dead. It will just discard the packet. Okay. Okay, so it comes down, and in this stage, it checks if traffic is an SSL enabled traffic or SSH enabled traffic, and if it is so, it checks for the SSL decryption rule if applicable, and it is capable of decrypting the packet if the SSL decryption is enabled. So we will not be able to know what is inside an SSL packet or what is being accessed because it is encrypted. So if the decryption rule is present with a valid certificate, you will be able to decrypt the packet and see what is inside, and you will be able to inspect that too. Okay, provided there is a policy for that. Okay. Okay, so now it comes to application identification. Okay, so it checks if we have app override policy. So in this case, this is a custom-based app that we can define in the Palo Alto firewall itself, and if it matches that, it picks up that application as a valid application. If not, it checks the pattern-based application identification. So it has a specific pattern to identify or application signatures to identify which application the user is using. So it checks that pattern and then looks up, after identifying the app, it looks up the policy for that application. So earlier we did a policy lookup with application as any here. So here we again do a policy lookup with the matched application and see if it is allowed. Okay. And in this case, parallelly, it checks for the content inspection also. Content inspection is basically your security profiles, where you will be checking antivirus profile, anti-spyware, anti-malware profile, DOS protection profile, file blocking, wildfire signatures. So all these are security profiles to identify if there is any threat in your specific traffic. And after configuring these profiles, you'll have to put that up on your security policy. And for each policy, if you have a content inspection or a security profile enabled, all these profiles will be reviewed upon before the traffic is allowed. Okay, so if there is any threat identified, the traffic will be blocked right there. Okay, so then the traffic comes to egress stage. So in the egress stage, it again does the same thing. It uses the ingress interface to get the forwarding domain, do the routing, and then forward the traffic to the egress interface. So it already identified what the egress interface is. Okay, it does the QoS shaping on if there is any QoS policies enabled onto the firewall. If not, it just checks if the fragmentation is applicable. If the traffic is set to be allowed on with the same packet that is received on the firewall, or it has to be fragmented. Okay, if it has to be fragmented, it does fragmentation. And then finally, if you remember in the ingress stage, we did the decryption of IPsec tunnel. If it's a tunnel specific traffic, we'll do the re-encryption again and then follow the same process to exit the packet out. Okay. So this basically would be your life of a packet that Palo Alto would go through. This all happens in a span of few seconds or within a split second. You will not even notice, but you will be able to see a couple of information when you try to go through a session browser when a session is basically identified on your firewall. Okay. And on my agenda, I think we have a couple more to review. So first one would be your GUI. So let's just try to log into the firewall first. Let's see if the firewall is powered on. So this is a demo lab for me to show you what a firewall is about, and just to show you an overview of the GUI. But the actual lab would be looking like the lab that you saw when I first did an introduction to the course on that website that I showed you. So that will be the lab that we'll be working on. But for now, I'm showing it to you here in this short lab. So let me log into the firewall. So the default username and password. So this is a fresh firewall. I have did a reset before I started the session. So for a new device, a new box, your username and password would be admin and admin. And you will be asked to change the password after you try to log in for the first time. Okay, it will directly ask you to change the password here, both in CLI and GUI, whichever you try to log in. Okay, let's now log in with the new password. I think I would probably show you how do you configure the admin users on the firewall, and probably would show you how do you commit the change, and what you probably need to know as a pointers when you commit the changes. And we'll just configure a basic lab on how an internet access works with the through the Palo Alto firewall, right? So these 3 labs we can probably do today. Okay, so this will be your firewall GUI. Just I'll quickly go through each tabs that we have here. The dashboard tab will have basic information about your firewall and what's happening in your firewall. So basically, if you see the system log, it'll say what has happened just now. So with the firewall, so I just logged in, I changed my password, and I got an IP address, right, through DHCP. So all those will be monitored and logged here. So if you see here, it has authenticated for the user admin from this IP address. Okay. This IP is basically my local IP where I'm running this tab, right? Logged in via web, password change for user admin. So all the stuff that are happening on the firewall. So let's say if a routing change happens, if we have set up a monitoring for our internet IP address on our default route, and if the monitoring fails, the route will be removed from the firewall, right? So that's basically called what do you call it as the route monitoring. So if the route monitoring object fails, that will be visible on your system log. So whatever happens on the firewall for you, it is going to appear on the system logs. Whereas your pass-through traffic, where your user accesses something and it goes through the firewall, that happens and that's logged on your traffic log. So when you go to monitor, you will see traffic log. This will be your pass-through traffic on the firewall, and you also see system logs. This will be the traffic that comes and hits your firewall, right? Your firewall as a destination, or what happens in your firewall. Okay, so when you just so this will be your interface that you should probably know. What would be your type of your log that you should check. When it comes to routing, you should check if you filter the type as routing. Okay. When it comes to VPN log, you should filter the traffic based on subtype VPN. So likewise, you should know what type of log you're referring to, because when, let's say, your one of your IPsec VPN that you built on a firewall goes down, and you need to only check those logs, right? So there will be a lot of logs on your firewall that is going to be available, and you shouldn't be checking them one by one. You should be trying to skip other logs just for you to avoid unnecessary confusion. So you should know how do you filter with respect to your subtype, your type of log. Okay, so the system log and traffic log, that's the difference. The threat URL filtering, wildfire submissions are all the logs that are available for your various features available on your Palo Alto firewall. Let's say, for example, decryption is for your SSL and SSH decryption. So we saw this when we spoke about our packet flow, right? Okay, so that's about the monitor log. ACC, it's just a graphical interface for your network activity or threat activity or tunnel activity. So whatever maybe your log that you might be interested in, you can just go to the tab and see the graphs based on whatever parameters you would like to. Okay, you can just research onto it, and you can also set up your own time to view the logs. And dashboard, I told you about it. Policies, you just have your security NAT QoS policies, PBF decryption policy for your SSL decryption, application override, we discussed about it, your DOS protection, right? Objects, again, it is going to have all your security profiles, your address object, address group, service object, application group. EDL is again a topic by itself, so you can just wait for me to discuss about it in the session. That's pretty much it. Security profiles here. And at the end, you have authentication profile that you could define for your AD authentication. Log forwarding profile, you could just set up a log forwarding device on the other side and configure a profile here with its IP address, and then see your logs forwarded there. Network, all about your IPsec, routing, interfaces, zones, VLANs, right? All those stuffs are configured here. DNS proxy, DHCP, so all that, all those network related stuff configured here. And device specific to the firewall. So let's say you want to upgrade a firewall, you go to software, you got to download some threat updates, dynamic updates, your URL filtering updates. You go here, download them, license related stuff. You want to contact your support or generate a tech support file like you do in Cisco or any other device. You come here and do it, and certain links for you to contact Palo Alto. If you have a valid support license, you could contact them, open a support case, and all those stuff here. That's pretty much it. So regarding your management IP configuration, all are available here. Okay. So before I go on to configure anything on the firewall, I'll just let you know how do you access your firewall when you first receive it out of the box. So that's like you receive a firewall, you will be having a USB port that you can connect to your device, to your PC, and configure same network IP address 1.1, 192.168.1.1, and here it is 1.1.2. Okay, on your management port, right? And you can directly use your browser and access the firewall as I did, and your username and password will be admin and admin, right? That's it. Okay, so let's say you are not at the location where the firewall is, and your firewall is connected to a specific switch. You can just put your management interface onto a specific VLAN that's connected to the switch, and that IP address can be configured based on that VLAN, and you can make that network reachable onto your office where you're sitting, and you can just access the firewall from there remotely. So that's one thing. So that's just about making the network where the making the VLAN network where the firewall is configured to, and make the firewall reachable from your remote network. So that's one way of doing it if you're not next to your firewall. Okay, so this is the way of accessing the firewall if you are having physical access to the firewall, right? So it's about accessing the firewall when it's out of the box, brand new firewall. Okay, let's just quickly see. I'm not going to configure and show you, but then I told you about configuring a management interface. So let's see how it's done. I'm logging into the firewall with the username and password. So I think the first access, sorry. The first access that you will get after receiving a firewall would be our CLI. So after you log into the CLI, you want to configure an IP address similar to the IP that you have for your PC, right? So you get to configure mode. And once you're in configuration mode, you got to configure an IP with the command set device config system IP address, and you got to give your IP address. Let's say in this case 192.168.1.1. No. Okay. Net mask. Okay, so here, let's say I give you two scenarios where if your firewall is, if you're next to the firewall and you have a PC connected to your firewall, in this case, a direct point-to-point link, you don't need a gateway here, right? No gateway is required. But in case of the firewall connected remotely, let's say this is your firewall and you're connecting this to a switch, and this switch will have a VLAN, let's say 10.1.1.0. The firewall, maybe you configure the IP as .20 on the same network. For this firewall, when you're configuring IP of .20, it needs gateway IP address for it to reach outside, because your firewall needs to respond to you. You're connected to some other network in some other location. You're coming in through a VPN and accessing this network. And first thing you'll do is access the VLAN that this firewall will be a part of. So 10.1.1.10 might be your IP address on your switch, and this IP would be our first point of contact. And from here, this server or this switch should know where to forward the traffic, and the firewall should know where to forward the traffic back when it's in return traffic. So in this case, you need a gateway. So you should you should make sure when to use a gateway and when to not use a gateway. Okay, when you configure a management interface. So when you give a question mark, I think it's default gateway. Yeah, it's default gateway, and then you got to give your gateway IP address, maybe 192.168.1.10. Okay, that's pretty much it. It's more than sufficient for you to configure a firewall, and then you have to give a command called commit. So I haven't configured anything. So if I exit from the configuration mode and say commit, it will say okay, maybe it's committing my username and password change as I did. But this is how you commit. So you just give commit command, and then it just goes on to commit your changes 0 to 100%. So that's how you configure your management interface. And I didn't configure that yet because I need this interface to be active for me to access the firewall through my browser directly. So, okay. So how do we configure an administrator? So here, I have a user called admin that's by default created. So if you want to create one more, go create security-admin. Okay, create it here. Security admin, no authentication profile here because I'm using a local authentication with a password. So I say the same password. Okay, so here administrator type is dynamic. So if you say dynamic, so these 4 user types are there. Super user has no restrictions, has access to everything. Super user read only, it can see or read everything, but couldn't edit anything. Device administrator, same as super user, only difference is that it couldn't edit or see any changes that it could make on administrator tab, right? Device administrator read only, it's again similar to super user read only, but again it can't maybe see what's there with the administrator tab. Okay, so the four types. So let's try to check device administrator read only. Okay, so I give this user as security admin user as device admin read only, and I've given him a password. So let's click OK. Password profile here, it's nothing. It's just going to say, so if I go to password profile, it's going to say what length of password I can use, when the password could change. So all those basic information, okay? Expiration warning period. So that's just basic stuff. So you don't have to worry about that. So I'm just going to commit my change. So when you commit your change, when you basically commit your change, you can commit all the changes or only your changes made by your user. So what is the difference? Let's say there are 4 admins in your organization. All 4 of them are working on the same firewall, or let's say you're managing it through Panorama. If you do all changes, and if someone is making changes at the same time, you have more chances of committing their change too, and maybe they might be in the middle of a change, and if you just half commit their configuration, commit their half of the configuration where they are left to do with a few more, it might end up in an outage, right? So it's always good to commit your changes only. So you got to commit this one, commit changes made by admin, and give some descriptive name. Okay, and this tab would give you a preview of what changes you have made. So if you just click OK, it'll let you know what have you changed. So this is your running configuration. So let me also tell you the difference between running and candidate. So running config is basically your config that's saved and committed on the firewall. So the committed changes are called running configuration. Okay, so only when you commit your changes, the changes are applicable, right? Not like Cisco. So if you just accidentally go configure your physical interface of your Ether channel on Cisco, your network is down, right? So you are not supposed to do that, and you don't have a privilege of committing changes on Cisco device. That feature is not there, like Palo Alto, where if you just directly key in the configuration, it directly gets applied. So in this case, running configuration is the committed changes. Candidate is the changes that we have right now. So here the candidate configuration is the change that we did by for creating the admin here. Okay, so this is the candidate, and the running config is the config that is already committed. Okay, so this is the changes we did, and in summary, it's just a text format of seeing what changes you have made. So only the changes you have made. Okay. So let us commit the change. So there is also an option to validate your commit. So let's say your commit is failing for multiple times for whatever reason. You have made some misconfiguration, done some errors in the configuration. You don't want others to see that you have made some changes wrong, and each time the commit fails. So when the commit fails, it will be showing up on your tasks here, and it will always, let's say you have tried to commit 3 times, and the commit failed 3 times, and the 4th time you are trying to commit again. People will be seeing that your commit has failed 3 times and will not look good, right? So you could just do a validate and see if the commit is successful, validation is successful, so that you will be sure that the commit will pass when you actually try to commit the change. So this is as good as committing a change, but you're not actually committing it. You're just validating the commit. this configuration is valid, right? So that's how your commit validation is done. So when you go back, you have something called, okay, I think that's about it. So this is the changes that you can include or exclude in your commit. Let's say you've done changes on your device and network and policies and objects. You could just include or exclude your specific changes for you to commit or not to commit, right? So you just click on commit and it gets committed, and we'll log off and then log in again with the super user, device administrator read-only user, and see what do we see and what we don't. By the time it commits, you just unmute yourself and let me know have any questions so far on what we have discussed, because it looks like I don't see anyone interacting. So we're just sort of having a few minutes of interaction before we get started with the next topic. So maybe anyone else who has any questions so far or would like to repeat something or anything for that matter, you can just unmute yourself and let me know. Okay, no one? Yeah, I at least expect a couple of people to speak out. Okay. Okay, let's have a.
Hello.
Yeah.
Can you hear me?
Yeah, I can. You can. Yes, sir.
Yeah, I have a question. So the question is, every time I make configuration on Palo Alto, I need to commit it. There is no direct implementation without commit.
That is correct. That is only a positive side of it, because let's say you are configuring something wrong without your consent. You cannot, make the changes applicable unless the commit is done, right? And you also have another layer of security where you could validate your commit. I just showed you, and then commit your changes actually on the firewall for it to get implemented. So which is again, something that you should always do with all the firewalls that you are probably using, all the vendors, because in this case, FortiGate, I would say, doesn't have this feature. So you just click OK on a specific tab. Let's say you're configuring an interface, click OK, and it gets applied. So just like Cisco. So in this case of Palo Alto, that's a pretty good thing, because so sometimes it will be annoying to you. Let's say you're deploying a new firewall, you're pushing all the configuration changes from the panorama, syncing the template config and device group configuration. Sometimes it gives you a headache of not getting committed for whatever reason, but there is always a valid point to why it is not committing. So that's always there. But on the other side, if you think of not creating an outage or not doing any misconfiguration, we are, of course, we are all humans at the end of the day, so we get to make mistakes. So to at least avoid them 50%, we could use this feature of commit, where only if the validation succeeds, validation of the commit succeeds, you can go ahead and commit the change. That's one good thing that I would say with Palo Alto, which is not there with FortiGate.
Okay, but the another question is it possible to deactivate this commit feature for some reasons and activate it later, or it is there by default? You
No, it's there by
cannot.
default. You will not
Okay.
be able to do anything with it. That's a built-in feature, and you will not be able to change them. Yeah.
Okay, thank you. That is all.
No problem.
All right, I got a question. So this you're doing the commit, you can only do it from the web interface, and can you do that on the command line?
I mean,
Like,
yes, did it on the command line. Yeah.
You can, okay, yeah, you can do show compare if it's like Juniper or Cisco, you can do show config. It shows you the difference, and then if it's okay, you can do the commit. So you can do it from a command line too, right?
We can, but I'll have to let you know what is the CLI version.
Yeah,
of,
for that. Okay.
yeah,
All right,
it will be possible. So anything that you want you do on GUI is possible on CLI too. But probably if you would like to, I think you're asking about what. So let's say if you're running something.
If you want to check what the config, you know, if you configure. Show compare, show pipe, or show pipe compare, something like that. If it's Juniper, compare, then compare, space compare, like you're comparing something, and then enter shows
Yeah,
you
I understand your question.
Right.
I will probably let you know
Right.
if it's done on CLI, but if you just need a comparison in GUI, it is
use that.
Okay, if you go to config audit.
Yeah, that's fine.
You see here something like local running config, and you can compare any version of configuration you've committed. So let's say I've committed somewhere around 10 changes separately. So this is the first commit I did, right? And this one is when I did it on the CLI. And this one is when I did just now on the GUI. So there are two commits. And when I go to my comparison version here, so when if I have to compare my first and second commit, I could do that here. So I could say first commit, second commit, and then I just can extend my context to 20.
Yeah.
And I say go. It gives me the difference here like this.
Oh, that's cool. Yeah, I was asking, like, I directed a question to you guys, kind of like very new with security. So I was trying to, make sure that you guys can accommodate me. Like, you just jumped into Palo Alto. So what are the other ones? Which vendor operates? Works with? Who's the vendor for Palo Alto? I know we have Checkpoint. The other ones. So I was just trying to
the comparison. Yeah, I understand the question. So the comparison on the other side, I will be covering on. So let's. I thought of having this session a little bit interactive and also show you some labs. So that's the reason I didn't go over the difference between on the Palo Alto and the other vendors. But definitely we'll be going through them in our actual session when we discuss about when we get started with Palo Alto. The first session would be what a firewall is like and why we're going for Palo Alto, not for the other firewalls.
Okay. All right. Cool. You got me. Thank you so much. Thank you.
Yeah. Okay. So I think the commit is completed. So the one way of checking them is this. You go to task. You see that your commit is done. So how do you know that it's your commit? That's why you give a description, right? So we got description. It says what description you give, right? So this is one way of doing it. It is completed, which means the commit succeeded. And when you go back to this one, you have a command here that you could say show jobs all, and here it gives you final commit and the time when it got committed. So I would say mostly try using GUI because it's pretty user friendly, or mostly user friendly stuff that you could go with. CLI is sort of a little boring. Only thing that the CLI would be useful is when you do a packet capture or a debug. You could see this useful, but otherwise CLI is what you should be probably using for most of the configuration related stuff. Okay, so I think the config is committed. Let's log out and log in with the username that we have created. So according to the role that I've given to this user, I should only be able to read everything but not configure anything. So let's try to go to the same tab that we already know that we can configure something there, the administrator, and I shouldn't see. Okay, So in case of device administrator read-only or device administrator role, the administrator tab is always restricted. So you will not be able to see. There was another administrator called admin, but that's not visible here. So because I have logged in with this username, this is visible to me. Otherwise, this is not going to be visible. And also, I will not be able to make any changes with any of the tabs. So if I just go try to create an interface under network, and if I just go inside, even though I have a valid configuration to click OK, I will not be able to. This will not be a valid option to select for me, because I am in that sort of admin role. So I will not be able to edit anything here. So maybe for anything, so say if I'm trying to create an address object here, and I will not be able to add anything. Okay. So let us log out from here and log in back again with the super user. Okay, right now we will try to configure internet connectivity to this user sitting here. Let's not use this one. So this is not required for now. I'm switching it off. So let's try to see if I have any sort of configuration here on this PC. So all I need to have is the IP address. And for now, I think it's not connected to internet. So I see the IP, I have 10.1.1.1, and its gateway here is 10.1.1.10. So let me configure the same on the firewall so that they are in sync. So if I log into the firewall with the super user and I go to network, so the interface that points to the LAN is 1/1, and 1/2 is the internet facing interface, right? So let me configure both of them. So 1/1 here is LAN, and you have a lot of interface types, so don't have to worry. I think we'll be covering everything in our session. For now, you know that this interface should be layer 3 because we're going to configure an IP address. And virtual router is just another name for VRF that you call it in Cisco. So in Cisco, we have a default routing table. Likewise, in Palo Alto, you have a default virtual router. Okay. A zone, as I said, it's a description or identity that you give for a specific interface. So I say this as trust zone because it comes from inside, and I click OK. So you can configure zone in 2 different ways. You can just configure right from here, or you could go to zone and configure and then map the interface to that zone. So either way, it's going to be the same configuration. So you come to the interface and map the zone, or go to the zone and map the interface. Okay, anything can be done. So I go and configure the IP address. So this was the IP I saw as a gateway on the switch on the PC. So I give the same mask. Okay, I'll click OK here. So let's say if I want to access this interface for anything, let's say I want to try pinging my gateway from the PC. So that's going to be possible on a router directly without any special configuration. But on the firewall, you have something called management profile here. So what protocol you choose on this profile and apply it to the interface here is going to be applicable for this interface. And the interface will be available for these protocols only. Okay, so where do you configure the management profile? It's here, interface management, or you configure that and point it here, or you directly create it from here itself. So if you go to advanced on the interface that we created, you have something called management profile. So this is where you go and map the profile that you configured here, or you can directly create it like we did for the zone, right? So I say secure as a name. This is just a name that I give to the profile, and I say I'm allowing it only to access ping. So if let's say you are sitting inside the network and you're the admin and you want to access this IP address to access the firewall through HTTPS, you can enable that too. Okay, so this IP is accessible using ping and HTTPS. You can ping the IP address and you can use them for accessing in with HTTPS as well. Okay, let's click OK. And it's just warning us that management profile, you're applying it to internal interface. Are you okay to go with this change or something? Okay, let's click OK. And the other interface is 1/2. And 1/2, so this is my management network. Okay, so this EVNG is running on my local network, and on my local PC, I think I have the IP address of 27, and here it is 40. And my firewall, as again, management interface is connected to the management cloud 0, so it got the IP address of 9. Similarly, for my PC to access real internet, I'm going to connect my outside interface to the management network, and from there it gets started out. So here I'm going to give this DHCP, and the management network will give an IP to this one. So let us say this is layer 3 and virtual router default, and security zone is untrust in this case. So this one is internet. So I say untrust and I click OK. Cool. IPv4, and I'm not going to configure a static IP in this case. As I said, my management network will give me an IP through DHCP, like I did for the management interface. So I say DHCP client, and similar to the interface, I have this management profile created, and I'm assigning it here so that I can try pinging them at least. So let's click OK. Okay, the interface configuration is done. So right now I should see this interface coming up. Okay, I've not committed this yet. So the link state is down. So I'm going to commit this one. After I commit this, I should see this interface getting an IP address. Okay, so let's commit this and then try configuring our policies. Okay, while this gets committed, so any questions here for you guys? So I'm just committing this change because that's a good idea to do, because when you're doing a specific setup, let's say it's a new setup, you got to keep committing the changes then and there for different parts of a configuration. So let's say for setting up VLAN, so you got to create an interface, you got to create routing, and you got to create let's say objects, security policies, all those stuff. For each configuration you do, you try committing them then and there so that you know where the issue lies when you are running into an issue in between. So if something doesn't work after you configure everything and you try to commit and the commit doesn't succeed, you will not know, or it will take a lot of time for you to figure out where the issue lies. So instead, if you try to commit the changes then and there for a specific configuration, let's say I'm committing it after my interface config, and if I'm able to commit, I know that the interface configs are good, right? So if you do a IP address change and you see a different IP for what you're supposed to see, that's a different story. But in a logical versus, if you're making some error in configuration, this will help you a little bit to figure out where the issue is. This is committed. So let me go to policies. Okay, so I know that my user will be able to reach my gateway because that's the first layer 3 segment from the user's PC to reach. So it will be able to ping the gateway now. So let us check that. Okay, I'm able to ping the gateway. So which means up to my firewall, the reachability is good. And I feel I've got an IP here, which is good. I got 20, and the gateway is 24.1. As I said, this gateway is same as my PC's gateway here. So if I'm going back to check my RDP's IP address. So it's 24.27. It also has a gateway of 24.1. So basically, I'm connecting my management interface and outside interface to this 24.1 network, and it gives an IP address to us, right? So that's what is happening here. So that's the reason we get same network IP, and the gateway is also the same. Okay. So this is good. And I also need to have a default route pointing to internet on my gateway 24.1, right? So here I don't have to configure a default route with when my interface is a TCP client, because we have an option to automatically create a default route pointing to the gateway provided by the server. So this being enabled, you don't have to create a default route on your routing here, which is not necessary in this case. Otherwise, you should create a default route pointing to your ISP IP. Okay, so that's avoided here. So let's create a policy. So we have already created a zone for trust and untrust. So yeah, let me explain the policies here. By default, we have intra-zone and intra-zone default. So intra-zone, intra, as you know, it's same zone. So the traffic is from two similar zones, let's say trust to trust, it will be by default allowed. Inter-zone, if it's from two different zones, untrust to trust or trust to untrust, so any two different zones, it's denied by default. So which means if you want to restrict access for a same zone traffic, you got to define a policy. And if you got to allow access for a different zone traffic, you got to specify a policy, right? So that's how you overrule the two default policies that are available. Okay. Okay, let us go to the security policy section, create a policy. And give it a name, and it's from trust to untrust, from our users zone to my internet zone. So I'm not specifying any IP address here, source address, source user. So this is what I spoke about user ID. You can define, you can restrict the traffic based on the users itself if you can integrate the firewall with the AD. Destination zone is untrust, and I'm not considering the IP addresses in this case. An application, again, let me keep it as any this case, and action will be allowed. You click OK. The policy is done for internet, and if I go to NAT, I got to NAT my internal network to the outside interface IP. I'm basically going to do a PAT, and I go to original packet. Original packet will be on the user's perspective what he is basically accessing. So he's accessing from trust zone to untrust zone, and I can keep source and destination IP as any. Under translated packet, I'm going to translate the source alone. So destination, I keep it as none. And source translation will be dynamic IP and port. And it will be interface address of Ethernet 1/2. That is my internet interface. So here I can choose the IP address of the interface because, can you guess why? Anyone? Before this is the last config, last leg of config.
Yes. I think it's because you configure it as the DHCP, right?
Yeah, spot on. That's the reason why we cannot choose this IP address here.
Yeah, we cannot assign the static because it will keep changing.
That's correct. So every time the interface resets or the device reboots, we will be getting a different IP from the DHCP, unless and until we are controlling the DHCP and we have reserved the DHCP for the interface MAC address, we will be getting the same IP, different IP every time. So for that reason, we will not be able to choose the IP address here. So we are not choosing that, and we just enable the interface and click OK. So I'm commenting the change. I say internet access. I'm commenting only my changes. If you want to validate, you can do so, but I know that it is going to work. So let us commit. And once this succeeds, I should see my PC's internet connection to come up, and I should be able to browse anything or access or ping google.com or whatever, because I haven't restricted them based on any specific application called ping or anything. I've allowed everything for the time being. So everything from the user's PC should work towards internet. So let's just commit complete, and we will test them. Okay, the commit is successful now, and let's go back to our connection to internet. So if I go on to check my ping towards 8.8, I should lose the first ping, and then I should eventually get response for the second. Yeah. So, and I also got the internet access here. And if I try to ping with the name, I should be resolving the DNS as well. And let me try to run a continuous ping to this one and go check my session browser. So since we don't have a licensed firewall, I will not be able to see the traffic log here. So we go to session browser for the time being and see the traffic from trust to on-trust. And from 10.1 to 8.8. And first it teaches the DNS because I have given the DNS to be my Google public DNS. So it uses my DNS first, and then it tries to access, resolve the google.com as this IP address, and then I am using ping as an application. The traffic goes on. So if you wanted to see the forward and reverse flow, you can just click on this plus sign. It shows you flow 1 and flow 2 from client to server, server to client. And you should see the other information like session ID, timeout, and what application it uses and all those stuff here. So if the NAT is applicable or not, NAT source is true. Yeah. And what rule it hits, and QoS plans is 4. All the other information will be available here. So the session browser is most useful stuff. So if you want to see the same thing in the CLI, you could do so by going here and saying show session all, and you will see all the sessions. So probably if you would like to filter something, so session all filter, source. And if I'm just filtering with the destination, I just say destination and 8.8, and let's show me the DNS traffic. Oops. Okay, it doesn't have an active setting. Maybe it got purged. Okay, so that's how you do a basic configuration for internet access. I think that's pretty much it. I think we have spent close to 2 hours now. So I think we are almost done with our agenda. So if you guys have any questions, or if you'd like to note down the contact details, I'm posting that on the screen again. I think you should have got the update for the same on the chat window. So you can just make use of it to get yourself enrolled. Okay. And if you have any further questions, I'll keep the forum open for a couple of minutes, and we shall meet again in our session there.
Well, another session tomorrow, right?
No, that's what I initially said. We will be we have
Okay.
planned to have it as 1 hour session for Saturday and Sunday, but I did it as a 2 hour session today itself.
Oh, I got you.
So yeah, it's
All right,
just
so
you want
we'll be trying to register next week. So
yeah, that's
thank you very much. Yeah,
Yeah.
thanks. Really appreciate it.
Thank you. Thanks a lot.
Yeah, thank you.
Hello, I have a question, please. For Fortinet, are you going to also deal with Forti Manager, Forti Analyzer, or only FortiGate?
It will be NSE4, which is only FortiGate. FortiManager is again a whole different paper. So if it's NSE4, it's going to be only FortiGate. So I think I have been given an intimation to go with FortiGate NSE4, which will not involve FortiManager. So I'll have to talk to the management on what is the plan and what is the course outline is. So for now, as I know, it's only NSE4 FortiGate.
Okay.
Yeah.
Thanks for the information.
Okay. Anyone else with any queries before we call it today?
So after this class, the next thing, when is the next class? Like we need to register, then we start the class, or how
Yeah,
is
we
the
need to register it with the backend team with the contact details available in the chat. And the batch will most probably be starting in the following week or the next week.
Okay. And the classes is always Saturday and Sundays.
Yeah, Saturdays and Sundays. Yeah, I'm personally not sure of what the timing is, but if there is any time that's promised to you people, I think that's the time that we will be agreeing upon. But for now, I don't have any intimation as to what time we start, but it's going to be a Saturday Sunday batch.
Okay, thank you.
It'll most probably be if you are in US timings, it'll most probably be your early morning or in the evening session. So which will be my early morning in India or evening in India. So I am not really sure which part of the batch you will belong to for Palo Alto, but it will be either of these two that we will see ourselves in.
Yeah, usually it's this time or something like an hour earlier, but this time it is okay for us over here in the US. So
yeah.
All right, excellent.
And another question, you will be starting with Paul Alto, right?
Yeah, that's correct.
Okay. Thank you.
Okay, guys. So I think with regards to the enrollment and registration, you can contact the mobile number, phone number, or the email address that you see on the chat. I think with regards to technical stuff, I hope I have answered all the questions, and I hope to see you, each and every one of you, in this session there. Have a good day and take care.
Thanks, man.
Yeah, thank you.
Thanks. Bye-bye.
Goodbye.